Hello, pre-calc. This is Mrs. Crayer. I'm on page 11, more power rule. I want you guys to do the warm-up at the top and then, pause the video first and then do the warm-up at the top and then come back and make sure that you are really good with fractional exponents and negative exponents and all that before we start today's lesson. I'm actually going to pause it and the answers will be there when I come back. Okay, so you can see what I got for the warm-up. The exponent on the variable goes on the top of the fraction. The index or the root, the number that's in the, what some people refer to as the crack, goes on the bottom. This is in number 1, you'll notice there's no negative because that's not in the bottom of a fraction. In number 2, it's in the bottom, so it's negative. Then 3 is going the other way. I've got a fractional exponent. I want to rewrite it with a radical. 4, that's on the bottom because it was a negative exponent. Now I don't have to put the 2 there, but you can if you want. Okay, so today's lesson is going to take into account the power rule, but also like all these fractional and negative exponents. So last week was just learning the power rule for some pretty basic, most of them were just positive. There was a few negative exponents, but you didn't have any fractional exponents. So now we're going to have to apply the power rule using these fractional exponents. Okay, reminder, when I'm going to use the power rule, I want to be looking at an x to an exponent. I do not want to be looking at an x in a bottom of a fraction. I don't want to be looking at an x under a radical. So that's where rewriting is going to come into play. I don't need to do that for number 1 because it's already, x to the 1/3. So right away I'm going to take a derivative. So my notation should be f prime of x. And the notation is actually important to me. If I was rewriting this, I would not be writing f prime of x first. 1/3 x, and then I have to subtract 1 from the exponent. Now, you guys are not taking your tests and quizzes and stuff right in front of me. But if you were, this would be on the no calculator section. So to me, it's important that you just have some sort of method to be able to subtract 1 easily, in your head. And the way I always do it is just subtracting, let me go to a highlighter real quick, subtracting the bottom number from the top number. So 1 minus 3 is -2. And then it stays over the same denominator. So there's my new exponent. So that first step was me taking a derivative. The next step is me rewriting the derivative because your answers need to be written without fractional or negative exponents. Okay, so this might seem tricky. I don't know. I'm going to put a 1 there, and I'm going to put a big denominator. The 3 is in the bottom. I'm also moving the x with a radical to the bottom. Now, how do I know it goes to the bottom? Because it's negative. How do I know it's a radical? Because I have a fractional exponent. So the 3 goes in here. And the 2 goes there. Okay. All right, I'll do number 2. Okay, number 2, no need to rewrite first. I can start by writing the derivative. The derivative here, since that was called y, I'm just going to use y prime. Bringing down that, there's no coefficient for me to multiply it to, just 1, so it's 4/3. And again, using that little thing where I subtract the bottom from the top, 4 minus 3 is 1, and it stays over 3. No negative or fractional exponents. This time, I'm not moving it to the bottom. Why would I not be moving that to the bottom? Because it's not negative. Now, I could put it right on the top of the fraction with the 4 or next to the fraction. Either answer would be fine, just as long as it's not in the bottom. 3 is a gotcha problem. Like, this is where I would, have people be trying a couple of these on their own, and lots of people would have the wrong answer for number 3 just because it's power rule. We want to take that 2 and multiply it to the 7, and we want to say it's 14. But it's a trick because 7 squared is just the number 49, and the number 49 is a constant, and the derivative of a constant is always 0. Derivative of a constant is 0. Okay, so that was just thrown in there just to kind of recap. Which ones do I want to do? We will do, I'm going to start now with 6, okay? You guys can certainly do 4 and 5. I'm just trying to make this video not be super long. And you can check my answer key for those. That'll be good practice. But I want to go through this one where we're going to have 3 steps. So I'm going to make this bigger. And the reason we're going to have 3 steps is because I'm not looking at x to an exponent. I mean, I guess 2, but that's not correct if I'm thinking of what the exponent on x is, because there's a radical there. So my first step is to rewrite, and you'll see this all over my answer key. I think it's just really important to note that I'm not taking a derivative yet. I am rewriting this. My next step is going to be the step where I take the derivative. Two-fifths comes down, x. 2 minus 5 is going to give me a negative 3, and it stays over the 5. That's how I can subtract 1 pretty quickly without a calculator. My last step is a rewrite. I'm taking this derivative. So the only pre-calc work in this step is, if you're following my color code here, is the green step. That was me applying the power rule. I went from the regular function to the derivative. What I did in blue and what I'm going to do here in the last step is just rewriting it. These are exponent rules. You start exponent rules in algebra. They're not really this tricky in algebra, but you do them again in algebra too. I'm making a big fraction. Why am I doing that? Because I know that this x needs to go on the bottom. How do I know the x needs to go on the bottom? It's a negative exponent. 5 goes in the root. 3 goes right there. No more negative. I've taken care of the negative by putting that in the bottom. Okay. I think now would be another good time to pause it, and you guys try 7 and 8, and then come back and I'll have the work and the answers done, and then we'll end by doing number 9 together. Okay, so you're going to pause it, do 7 and 8, unpause it, see the answers, and then we'll do 9 together. Okay. So here's my answers for 7 and 8, and you can see my work as well. My first line in red is me rewriting. So that's why you still see the notation f of x in 7, and you still see the notation y equals in 8. In the blue line, I've applied the power rule. Now, just to point out in number 8, sometimes people will, because this guy is set up to take a derivative, sometimes people might take the derivative there. Well, that would be wrong. If all I'm doing is rewriting, then I should not be applying the power rule anywhere. If any term in the function is not ready for the power rule to be applied to it, then if x squared is fine how it is, then you just leave it x squared, because that whole first line needs to either be the function or the derivative. Not, one term we took the derivative of and the other term we just rewrote. All or nothing. Okay, so then the blue part is the derivative, applying the power rule, and then the last line is rewriting using our rules that we know. Okay, move this over here. Now we've got 3 terms. Try to be maybe 1 step ahead of me, I would say. So the first thing I'm going to do is rewrite it. They all need to be rewritten in every single case. And this is kind of a nice one for seeing every single case. F of x equals, this is going to be 2x to the 1/2. There's no negative there. plus 7x to the negative 4. That one's negative because it was on the bottom. I'm just not getting much better at writing on this thing, but I am trying. Minus 6x, sorry, there's no, in the last term, there's no fractional exponent because there was no radical. And then the last one's going to have both. It's going to have a negative because it's on the bottom, and it's also going to have the fractional exponent of 2/3. Okay. Now we go to a different color. Now I'm doing the derivative. So that first step was just a rewrite. That's why it's still called f of x. Now I'm actually going to apply the power rule. So applying the power rule, 1/2 times 2 makes that exponent, or that coefficient a 1. 1/2 minus 1 is negative 1/2. Negative 4 times 7, the new coefficient is negative 28. Negative 4 minus 1, when you're working with negatives, don't forget, minus 1, we're going down the number line, negative 5. Negative 2/3 times negative 6 is going to be a positive. And then if I think about it in terms of like 6 times 2, since those would both be on the top, 12 over 3, that's going to give me a 4. And then again, subtracting the bottom from the top to subtract 1 from this fractional exponent. I have to think of, just keep the negative in the top. Negative 2 minus 3 puts me at negative 5. And then it stays over 3. So there's my derivative. That is the derivative for that function. How do I want your final answers written, and how will they typically be written on like an AP Calc exam if it was multiple choice, without these fractional or negative exponents? So in the first one, that's going to the bottom because now it is a negative exponent, and it's just a square root of x. Minus 28 over x to the 5th. No radical there because I don't have a fractional exponent. And then this one is going to have a radical. Notice the 4 is on top. The 4 is not being raised to a negative exponent. 5 is the exponent. 3 is the root. And there is the final answer for the last one. That's as complicated as it gets. Number 9. You've got multiple terms. They all needed to be rewritten. There's negatives and fractional exponents, and then you have to write them all again. So that's as difficult as the power rule gets. Okay, so now at this point in the packet, we talk about some things that we need to know. I start getting into some other derivatives. And this is just because, like, if you see them now for a few days, then, and kind of practice them, then when we start working more with them, we have them down. Like if I don't start doing these until, day 12 or whatever, then it's like brand new information. But I'm kind of like pepper them in a little bit here. So the derivatives that we work with the most are derivative of sine, derivative of cosine, derivative of tangent. We don't get into all the other ones in pre-calc. Derivative of e to the x and derivative of ln of x. But before I get to that, let me grab my highlighter. You saw me use y prime and f prime of x above, and we've been talking about how the derivative, you use that prime notation. Well, there's this notation as well, and this is going to be heavily used in AP Calc. And it is dy over dx, but the way it's said is dy dx. Like when you read that in a problem, and you'll hear that 100,000 times next year. dy dx, dy dx, dy dx, dy dx. It's the same thing as y prime or f prime of x. Okay, it's the way of saying, just another notation for the derivative. So I just want you to start getting used to seeing that too, because I don't know what directions I used above. I'm going to go see if I can see. I just kind of wrote it in words to find the derivative. But if I wrote find f prime of x or find y prime, at this point I would expect everybody to know that that just means find the derivative. But after today, now I expect you, when you see find dy dx, I expect you to know that this means, this means the derivative. Okay. And now to the derivatives, we're going to start memorizing, I would say. The derivative of sine is cosine x. The derivative of sine x is cosine x. The derivative of cosine x, you want to say sine x, you're close, is negative sine x. The derivative of tangent, there's my new notation, dy dx, is secant squared x. We'll use these a lot. This is just the first time you're saying, you're like, oh my gosh, do I have to memorize this? It's like, yeah, but you do enough problems, you'll memorize them. The derivative of sine is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. For the first two, when we get more into the graphs, I'll kind of show a little bit more about that. That'll help solidify that. But for right now, it's just, hey, these are the derivatives. Try and start getting to know them. This is why e to the x is kind of special, because the derivative of e to the x is, use red, e to the x. It's itself. That's a pretty crazy feature. And again, as we talk more about the graphs and stuff, we'll talk about what that means. I mean, just kind of get into it a little bit, because I think we can handle this at this point. But you guys know e to the x is an exponential function, specifically exponential growth. And every time we were doing those derivatives for the first few days, you know, most of them were parabolas. And I would say, okay, you know, you just found the derivative at 2, you know, and if the derivative at 2 was 7, that did not mean that this point was 2, 7. That point could be anything, 2, I don't know, 13. That meant that the slope of the tangent line there is 7. Well, if the function and the derivative are the same, that means that whatever the y value is right there, that's the same as the slope of the tangent line for every single point along the way for this whole function. It's a pretty unique characteristic. Okay. Okay, that's the rate at which it's changing happens to be the same as the output. Okay, the next one, ln of x. The derivative is 1 over x. Okay, so there are 5 functions that are not polynomial functions. You know, polynomial functions, we just did a number 9. We just decided that no matter how difficult you make, well, that's not a polynomial function because it's got all those other things in it. Yesterday was polynomial functions, well, last week. But no matter how difficult you make a function that has all separate terms, because polynomial functions don't have negative exponents and radicals and stuff like that, so I misspoke. But no matter how difficult you make it, we could apply the power rule. But you can't apply the power rule for these specific functions. You know, sine x is a very specific trig function. Cosine x, tangent x, same thing. E to the x is an exponential function, ln of x. You can't apply the power rule to those. It doesn't work that way. The power rule doesn't work when you have x and an exponent. Okay, the power rule works when you can write it as x to an exponent. Okay, even though I skipped a few problems, I still managed to go like 19 minutes here. All right, hopefully that wasn't too long. I think you guys will be fine with these, but you know, just sometimes a little in-depth explanation helps. Check the answer key for 4 and 5, and you know, do the practice problems on the homework and check those on Tuesday, and just make sure you're staying up with it, because all this stuff is really important for next year. Doable, definitely doable, but really important for next year. All right, hope everybody's doing well.